So students, what will be the dimensions of tau? This will be tau equal to f cross r or tau equal to f r sin theta or f into the perpendicular distance, that is f dot l. What is the dimensions of student? That is m l t minus 2 into l. So this becomes m l 2 t minus 2. So dimensions of mass here is +1, and also this does not have negative dimension in mass student. Okay, then let us see what is coefficient of thermal conductivity. You know student, thermal conductivity is coefficient of thermal conductivity is denoted by K. And what is its formula? Okay student, that is denoted by K. Suppose this is a slab student, thermal slab, and we are hitting at this point. This thermal slab have length L, this is length L, and suppose this is a cross-sectional area A, and suppose we hit here. So the temperature here is T, and the temperature here is T. When we hit it, it becomes T plus delta T, and due to this temperature difference, heat will flow from this position A to this position B. Student, you know heat flows in the direction of the lower heat area. So the time rate of flow of heat, that is dq by dt, will be directly proportional to the cross sectional area. It will be inversely proportional to the length of the tube, and it will be directly proportional to student the temperature difference delta T. So dq by dt can be written as k A by L delta T, where K is the proportionally constant called the coefficient of thermal conductivity. Student, okay, from this formula we can get the formula for coefficient of thermal conductivity. Okay students, so the formula for K will be equal to dq by dt divided by, this is A by L, when goes the side this becomes L by A, and del T will be here 1 by delta T. Okay student, then this is dq means mlt minus 2, the dimensions of energy, heat energy, this is heat energy, and we know every energy has forms the dimension ml2 T minus 2 divided by T, and this is L by A means length by length square. Okay student, area has dimension L2, and 1 by delta T we write it by K, degree Kelvin, you know K. Okay student, then what it becomes? It becomes T, L square cancel out. Okay, M, this is L, this T is there, when goes upward this becomes T to the power minus 3, and K inverse. This is the dimensions of coefficient of thermal conductivity. So the dimension of mass is here also 1, and therefore student, this also does not have negative dimension of mass. And let us find out what is the dimensional formula for universal gravitational constant capital G. Okay student, we have studied Newton's law of universal gravitation, Newton's law of universal gravitation. What does this law state student? This law states that if there are two masses m1 and m2, okay, separated at a distance r, then they will attract each other with a force F that will be directly proportional to the product of their masses and inversely proportional to the square of the distance between them, students. And here we may write this as F is equal to G m1 m2 by r square, where G is the proportionally constant called the universal gravitational constant. Okay student, from this we can find out the formula for G, that will be equal to Fr square divided by m1 m2. So what will be the dimensions of G student? Dimension of G will be dimension of F, that is mlt minus 2 into dimensions of r square, that is L square divided by m1 m2 means m to the power 2. Okay, student. Then this m cancels this m, and this becomes n. L into L2 means L3 t to the power minus 2. If m goes upward, so this becomes m minus 1. Okay, student. So here we find that mass is negative dimensions. So the correct option is option D, students.